Okay, so today we're going to talk about reference angles. Reference angles of an angle in standard position is the positive acute angle or the right angle formed by the x-axis and the terminal side of the angle. So what's really important here, I don't know how to stress this enough, is the x-axis. You will absolutely never ever go to the y-axis. It is always the x-axis. So I'm going to write that really big. Oops, in red. Always x-axis. Write that, star that, circle that. I cannot stress that enough. I don't know how to stress that enough. Okay. So, for example, if I draw a coordinate graph and I draw standard position. So let's just say I choose 120 degrees. So this is the standard position, but what we're talking about today is the reference angle it creates. And so you have to keep in mind you're going to go to an x-axis and you want to form an acute angle. So you know the standard angle you created is actually obtuse. So you don't want to be going to this x-axis. That forms an obtuse angle. You want an acute angle. So instead, you're going to say, well, this is the reference angle, and I know that if this represents 120, the whole thing is 180. We know supplementary angles from geometry way back when says that this would be 60 degrees. And now you say that 60 degrees is theta ref. Alright, so let's do some. Find the reference angle of the following angles. So 50 degrees. 50 degrees is right here. Now, this is an interesting case because I'm in quadrant 1, and as you can see, I'm going to an x-axis and I have an acute angle. So this theta is equal to theta ref is equal to 50 degrees. That's what happens always in quadrant 1. So we can go ahead and write that right here down at the next little section. Theta ref is equal to theta standard S. Alright, let's do 130 degrees. So this is similar to that example I showed you up above. So 130 degrees, we know if this is 0, 90, 180, 130 is somewhere over here. So let's first draw the standard angle. So this is the standard angle of 130. But this is an obtuse angle, which is not what I'm looking for right now. I'm looking for theta ref. So I'm going to bring that terminal side down to the closest x-axis. If this is 130, this is 50. So theta ref is equal to 50. So look at these theta refs. They're the same, but we didn't start off with the same standard position. That's very common to happen. So here, what did you actually do? You did 180 minus 50. So 180 minus the theta standard got you theta ref when you're in quadrant 2. Now let's go to quadrant 3, 220 degrees. So draw 220 degrees. So 220 degrees is in quadrant 3. Now, of course, this is a huge angle right here. That's by no means acute. So you're going to take this terminal side right here, go to the closest x-axis, always the x-axis. This is the closest x-axis. So this is theta ref. If this is 220 degrees, this is 180, then this is 40 degrees. So now we did theta standard minus 180. Alright, and then finally 325 degrees. So draw your coordinate graph. 325, we're in quadrant 4, so that's right here. Keep in mind, this is what 325 degrees is. That's by no means acute. So I'm going to take my terminal side and I'm going to go to the closest x-axis. So if this is 325 degrees, that's 35 degrees away from the closest x-axis. So I got that by doing 360 minus the theta standard given. This last part says if theta is a quadrantal angle, which means it lies on the quadrant boundary, or you could think of it that as the axis, then theta ref is equal to 0 degrees. Oops, that's a degree. 0 degrees or 90 degrees. All right, let's go on. All right, so we want to identify in which quadrant each angle lies. So if I think about 7 pi over 4, when you're thinking about these angles, you really need to think about where it lies on the graph first and then go to the closest x-axis. So this is positive radians, so we'll go in the positive direction. And we need to go in the positive direction by 7 pi over 4. So hopefully you're familiar enough with your radians to remember that this is 0 pi on the starting place, and this is 1 pi, and this is also going to be 2 pi. And we're going in this counterclockwise direction. But it's really hard to compare a number with a denominator of 4 if you're not comparing it to other denominators of 4. So what I need to do is I need to multiply these by that magic number of 1. So I'm going to multiply 4 over 4 here. So really, instead of thinking of just regular pi here, I'm going to think, well, this I could say is 4 pi over 4. So 4 pi over 4. And rather than thinking about 2 pi here, I'm going to multiply 4 over 4. And so you could also be thinking of this as 8 pi over 4. So 7 pi over 4, if you realize I just passed 7 pi over 4 when I went to 8 pi over 4. Now, so it's somewhere in between 4 pi over 4 and 8 pi over 4. Exactly in the middle of 4 pi over 4 and 8 pi over 4 is this y-axis going down. And 4 and 8, exactly in between 4 and 8 is 6 pi over 4. So now you can very clearly see that 7 pi over 4 is going to be exactly in the middle of 6 pi over 4 and 7 pi over 4. So this represents 7 pi over 4 right here. But the question is saying draw the reference angle, and so what I'm drawing in green right now is actually the standard angle that we learned last week. So if you're wanting the reference angle, I'm going to do that in red. That's to the closest x-axis, which is right here. And if this is 7 pi over 4, and this is 8 pi over 4, then they are exactly 1 pi over 4 away from each other. Okay? Alright, let's do, I guess let's do C. So 11 pi over 7. So this is a little bit harder because it's an odd number and you can't cut odd numbers in half as easily. But still, so this is going to be 0 pi. This is 1 pi. let's automatically, rather than thinking about 1 pi, let's think about 7 over 7. So this is 7 pi over 7. So this would be 14 pi over 7. So I've just passed my 11 pi over 7. So what we have to determine is it in quadrant 3 or is it in quadrant 4? Because before we start, we have to figure that out either way. So 7 pi over 7 compared to 14 pi over 7, these are 7 pi over 7 away from each other. So exactly half of 7 is 3.5. So 7 pi over 7 plus 3.5 is 10.5 pi over 7. So I'm almost at 11 pi over 7, but I haven't quite made it there when I'm at 10.5. So you're going to have to go just a little bit further. So that means we are in quadrant 4. So this, I could say, represents 11 pi over 7. If this is 11 pi over 7, look at the 14 pi over 7 that is closest to it. How far away is 11 pi over 7 to 14 pi over 7? So 11 compared to 14 is 3 pi over 7. That's your theta ref. All right. Let's do, I don't know, let's do h. So if we do h, now we're looking with denominators of 13. So this is 0 pi. This is 13 pi over 13. Still not there. So this is 26 pi over 13. Still not there. Add 13 is 39 pi over 13. So I've passed it. Now, you can probably just tell that 36 is closer to 39 than 26. So you could just go ahead and start drawing, and you're going to be in quadrant 2. If you want to convince yourself of that, half of 13 is 6.5. So this would be 32.5 over 13. But you really don't need to do that. Alright, so if this is 36 pi over 13, and my closest x-axis is right here, and that's at 39 pi over 13, then this represents 3 pi over 13. Okay, that's going to be it for today's lesson.